Hello everyone, it's Megan from KenHub here, and in today's tutorial we're going to be looking at the skeletal system of the body. The human skeleton is the framework that gives your body shape and support, and essentially stops you from being just a blob on the floor. Think of it like the wooden beams that make up the internal framework of a house. Now, the human skeleton is made up of more than 200 individual bones, 206 to be precise. And these bones are connected to each other through articulations, ligaments, and tendons. Before we begin, let me first give you a quick overview of what we're going to talk about today. So the first important fact to establish here is that the skeleton can be divided into two main parts. The axial skeleton, which is essentially the core central region of the skeleton, and the appendicular skeleton, which consists of the bones attached to this region, or the appendages. Now, the axial skeleton consists of the skull, which can be divided into the bones of the neurocranium and the bones of the visceral cranium. It also consists of the trunk, which includes the vertebral column or the spine, the rib cage, and the sternum, also known as the breastbone. The appendicular skeleton, on the other hand, consists of the shoulder girdle, the bones of the upper limb, the pelvic girdle, and the bones of the lower limb. Don't worry, we won't be looking at every single bone of the body or we'll be here all day, but we will touch on some important points relating to the main bones of each region. So let's start with the axial skeleton, where we'll begin with the skull, starting specifically with some of the bones of the neurocranium. You might be wondering what on earth neurocranium means, but basically it refers to the portion of the skull that houses and protects the brain. We're going to look at three bones of the neurocranium, including the frontal bone, and if we flip our skeleton to view it from behind, we can see the two other bones, the paired parietal bones and the occipital bone. It's worth noting that the temporal bone, the sphenoid bone, and the ethmoid bone also make up part of the neurocranium, but will not be discussed in this tutorial. So let's flip our skeleton back around so we can see the first bone of the neurocranium that we're going to talk about today, which is the frontal bone. And let's zoom in a bit so we can see this bone a little clearer. As you can see, the frontal bone is situated anteriorly and it encompasses the area of the forehead. Moving posteriorly, we have the parietal bones, which articulate with the frontal bone and are also bones of the neurocranium. These paired bones are situated on the top and sides of the head, and if we zoom in slightly, we can see that they're connected to each other at the midline of the roof of the skull via the sagittal suture, which is an example of a fibrous joint. Finally, we have the occipital bone, which is highlighted in green in our image on the right. Again, we'll zoom in for a closer look. The occipital bone is the most posteriorly situated bone of the neurocranium. And as well as protecting the brain, it also provides attachment for various muscles of the head and neck. Now that we've looked at some of the bones of the neurocranium, let's move on to the bones of the visceral cranium. Again, visceral cranium is a bit of a lengthy word, but it simply refers to the bones that form the face. We're going to look at two bones of the visceral cranium, the maxilla or the upper jaw, and the mandible or the lower jaw. Again, these are not the only bones that make up the face, there are several more, and if you'd like to know a bit more about the bones of the visceral cranium, our tutorial on the bones of the head and neck is available on our website. So here we see the maxilla, which is a vital bone of the face. This bone, which is also known as the upper jaw, contributes to the formation of the orbit, the nose, and the palate. Let's zoom in so we can see it a bit better. If we flip our skull to view it from below, we can see that it also houses the upper teeth, and therefore plays an important role in mastication and communication. The mandible is the other bone that makes up the jaw. It's also known as the lower jaw and is the only bone of the skull that doesn't articulate with other cranial bones via sutures. If we switch perspectives to view our skull from the side and zoom in slightly, we can see that it actually articulates with the temporal bone via the temporomandibular joint, or TMJ, which I've circled for you on your screen. The mandible houses the lower teeth, and like the maxilla, it also plays an important role in mastication and communication. Now that we've seen some of the bones of the skull, let's move on to have a look at the bones of the trunk, starting with the vertebral column. The vertebral column or backbone is made up of 33 vertebral bones known as vertebrae that are connected to each other through numerous joints. It can be subdivided into the cervical vertebrae, the thoracic vertebrae, the lumbar vertebrae, the sacrum, and the coccyx. Most of the vertebrae have a similar basic structure, which I'll go through with you now using an image of a superior view of a lumbar vertebra. So the first region we can see highlighted is the body. Your typical vertebra will also exhibit 2 pedicles, 2 laminae, a spinous process, 2 transverse processes, and 4 articular processes. Note that we can only see 2 articular processes here, as the other 2 are located on the inferior surface of the lumbar vertebra. The 2 vertebrae that don't exhibit this basic structure are the atlas and the axis. The atlas is the first cervical vertebra, C1, and is the only vertebra that forms an articulation with the skull, supporting the head, much like the Titan Atlas was forced by Zeus to support the earth. Let's isolate this bone and zoom in a little bit so we can see its structure clearer. Looking at this superior view, you should now be able to see that the atlas is unique amongst the other vertebrae because it doesn't have a body or a spinous process. The atlas balances on and articulates with the axis, which is the second cervical vertebra, C2. Again, we'll isolate this bone and zoom in so we can see it better. The axis is unique because it has an odontoid process, also known as the dens, and this is the part that articulates with the atlas. So far we've focused on individual vertebrae, but we also have some fused vertebrae. The sacrum is actually made up of 5 fused sacral vertebrae, and as you can see, it's located at the base of the spine. If we zoom in a little, we can see that this irregularly shaped bone forms a link between the spine and the pelvic bones via the sacroiliac joints, which I've labelled for you on our image. At the distal end of the sacrum is the coccyx. If we zoom in slightly, we can see that the coccyx is made up of 3 to 4 fused coccygeal vertebrae. It's the last part of the vertebral column and is connected to the sacrum via the sacrococcygeal joint. Continuing with the bones of the trunk, next we'll look at the bones of the rib cage. Now there are 12 ribs that make up the rib cage. Let's zoom in so we can see them better, but keep in mind that in our close-up we're viewing the ribs from a posterior perspective, whereas our skeleton showed them from an anterior perspective. Although all 12 ribs articulate with the vertebral column, only 7 of them articulate directly with the sternum, and we can see these ribs highlighted in green in our image on the right. These first 7 ribs are what are known as true ribs because they attach to the sternum directly via their own costal cartilages. The 8th to 10th ribs, on the other hand, are known as false ribs because they articulate with the sternum indirectly through the cartilage of the 7th rib. The last 2 ribs are known as floating ribs because their costal cartilages tend to end within the abdominal musculature. The last structure of the trunk we'll look at today is the sternum or the breastbone. Now the sternum is composed of 3 parts: the sternomanubrium, the sternal body, and the xiphoid process. We'll explore the sternum in a superior to inferior direction, starting with the sternomanubrium. The manubrium is a quadrangular shaped bone, and if we zoom in we can see that it articulates with the clavicle, the first rib, the sternal body, and the second rib. The body of the sternum, or the sternal body, is a flat bone with a convex anterior surface and a concave posterior surface. Let's take a closer look. So the sternal body is quite easily palpable and it forms articulations with the manubrium, the 2nd to 7th ribs, and the xiphoid process. So lastly, we have the xiphoid process of the sternum, which is a small bony projection, as you can see in our image on the right. If we zoom in slightly, we can see that the xiphoid process possesses demifacets for part of the 7th costal cartilages. It also articulates with the sternal body. Now that we've looked at the components of the axial skeleton, the skull and the trunk, let's move on to the appendicular skeleton, starting with the shoulder girdle. The shoulder girdle is made up of 2 bones, the clavicle and the scapula. Let's go on to look at these bones in a little more detail. So as I just said, the clavicle is one of the bones of the shoulder girdle. This long bone articulates with the acromion of the scapula, forming the acromioclavicular joint, which you can now see highlighted in green. The acromioclavicular joint is also known simply as the AC joint. Now let's look at the scapula. This bone is a flat triangular bone, also known as the shoulder blade, and is located posterior to the rib cage. Let's talk about some key features of the scapula, starting with the acromion. If we change perspective so that we have a posterior view of the scapula and zoom in slightly, we can see how the acromion of the scapula articulates with the clavicle to form the acromioclavicular joint. Another feature of the scapula that we'll look at is the coracoid process. Let's see what this structure looks like on our anterior view of the skeleton. You can see that it's a hook-like bony projection and that it's situated superior to the glenoid cavity. The head of the humerus articulates with the glenoid cavity to form the shoulder joint. To see the last feature of the scapula that we're going to talk about, we need to flip our skeleton. The spine of the scapula is a protruding bony ridge on the posterior surface of the scapula that is easily palpable and separates the superior spinous fossa from the inferior spinous fossa. Now that we've covered the shoulder girdle, let's move on to have a look at the bones of the upper limb. In this section of the tutorial, we'll divide the bones of the upper limb into the bones of the arm, the bones of the forearm, and the bones of the hand. Luckily for us, there's only one bone in the arm, and that is the humerus. The humerus is a good example of a long bone. At the proximal end of the humerus is the head of the humerus. If we zoom in a little, we can see that the head of the humerus articulates with the scapula, forming the structure we can now see highlighted in green, which is the shoulder joint. This joint is also known as the glenohumeral joint because the head of the humerus sits in the glenoid cavity of the scapula. Now back to our lovely skeleton here. On the lateral aspect of the humerus is a bony prominence known as the greater tuberosity, seen in our image highlighted in green. And situated on the anterior aspect of the humerus is another bony prominence known as the lesser tuberosity. Between these tuberosities lies a deep groove called the intertubercular sulcus, which provides a channel for many structures. At its distal end, the humerus articulates with the radius and ulna of the forearm, forming the elbow joint, seen here within the blue circle on your screen. Next, we're going to look at the bones of the forearm. As you know, the forearm is the part of the upper limb found between the elbow and the wrist. It has two long bones, which are the radius and the ulna. The radius is situated laterally and is the shorter of the two bones of the forearm. At its proximal end is the head of the radius, which forms an articulation with the capitulum of the humerus as part of the compound joint of the elbow. At the distal end of the radius is a downward bony projection known as the styloid process. Let's look at some more articulations that the radius forms with neighbouring bones. The head of the radius articulates not only with the humerus but also with the ulna to form the proximal radio-ulnar joint, which as the name suggests is situated proximally. Distally, the radius articulates with the ulna again to form the distal radio-ulnar joint. In addition, the radius also articulates with the carpal bones of the hand, specifically the scaphoid and lunate bones, to form the radiocarpal joint. The other long bone of the forearm is the ulna. It has a bony protrusion on its proximal posterior surface, which we can see if we flip our skeleton over. This protrusion is known as the olecranon and can be easily palpated at the elbow. Like the radius, the ulna also articulates with the bones of the wrist distally, and possesses a bony projection on its distal posterior surface, which is known as the styloid process of the ulna. Now let's move on to the bones of the hand. The hand is comprised of a number of bones: the bones of the wrist, the metacarpals, and of course the bones of your fingers, otherwise known as the phalanges. Let's start with the wrist. If we look at the wrist a bit closer, we can see that it's made up of the carpal bones or carpals. These include the scaphoid, the lunate, the triquetrum, the pisiform, the trapezium, the trapezoid, the capitate, and the hamate. Some of the bones of the wrist form articulations with the metacarpal bones. The metacarpal bones are the next row of bones in the hand after the carpals. Let's look at them a bit closer. There are 5 metacarpal bones, which consist of a proximal base, a shaft, and a distal head. The distal head of each metacarpal bone forms an articulation with the phalanges of the hand, forming the metacarpal phalangeal joints, as you can see here within the blue circle on your screen. Lastly, we'll look at the phalanges of the hand. The phalanges of the hand, as we have just seen, are connected to the metacarpals via the metacarpal phalangeal joints. 4 of the 5 phalanges of the hand, which correspond to the index, middle, ring and little fingers, have a proximal phalanx, a middle phalanx and a distal phalanx. The thumb, however, only has 2 phalanges, a proximal phalanx and a distal phalanx. The phalanges are connected to each other via hinge joints, which are known as the interphalangeal joints. So far we've looked at the bones of the skull, trunk, shoulder girdle and upper limb. Now let's move further down the body to explore the pelvic girdle. The pelvic girdle is formed by the pelvic bones, also known as your hip bones. 3 fused bones make up each hip bone, and they are the ilium, the ischium, and the pubis. So the first component of the hip bone we'll look at today is the ilium. The ilium has several notable features, including the iliac crest and the anterior superior iliac spine. The ischium, as we already saw, is one of the 3 bones that make up the hip bone. At the inferior surface of the ischium is a bony tuberosity known as the tuberosity of ischium. The final bone that makes up the hip bone is the pubis or the pubic bone. The 2 pubic bones are united via a cartilaginous articulation called the pubic symphysis, seen here in the image on the right. On either side of the pubic symphysis is a tubercle known as the pubic tubercle. Before we move on to the bones of the lower limb, let's first look at the joint which connects the pelvis to the lower limb, and that is the hip joint. This joint is also known as the acetabulofemoral joint. The hip joint is a ball and socket joint formed between the acetabulum of the hip bone and the head of the femur, which is why we call it the acetabulofemoral joint. The last group of bones we're going to look at today are the bones of the lower limb. So as I said, in this part of the tutorial, we're focusing on the bones of the lower limb, specifically the bones of the thigh, the bones of the leg, and the bones of the foot. Like the arm, the thigh has only one bone, which is the femur. The femur is the longest bone in the human body, and we can see it highlighted in green in our image on the right. If we zoom in on the proximal aspect of our femur here, we can see some key features, such as the head of the femur. The head of the femur, which we spoke about briefly when we looked at the pelvic girdle, articulates with the acetabulum of the hip bone. Next, we can see the neck of the femur, which supports the head of the femur. On the lateral aspect of the femur, below the neck of the femur, is a palpable prominence known as the greater trochanter, seen here. It's connected to another eminence on the posterior aspect of the femur known as the lesser trochanter by an obliquely running line called the intertrochanteric crest. I'm pointing to this crest with the blue arrow on your screen. Moving further down, we can see a distinctive ridge running along the posterior aspect of the femur. This ridge is called the linea aspera femoris and is an important site for muscle attachment. Now let's look at some features of the distal femur. First we have the lateral epicondyle, followed by the medial epicondyle. These epicondyles function as a site of muscle, ligament and tissue attachment. Below these epicondyles we have the lateral condyle, followed by the medial condyle. These condyles then articulate with the tibia of the leg to form the knee joint. On the anterior surface of the knee joint is an irregularly shaped bone called the patella. You might know this bone better as the kneecap. The leg, which is the region between the patella and the foot, has 2 long bones, the tibia medially and the fibula laterally. First we'll look at the tibia. The tibia is wider than the fibula, and as we saw, it articulates with the femur. The tibia is more commonly known as the shin bone. At the proximal end of the tibia are the tibial condyles. The lateral condyle of the tibia is situated laterally, while the medial condyle is of course situated medially. These 2 condyles carry the weight of the femur, and above them is a flat articular surface known as the tibial plateau, which articulates with the condylar surfaces of the femur that we saw earlier. On the anterior surface of the tibia, at its proximal end, is a palpable bony prominence known as the tibial tuberosity. And at the distal medial end of the tibia is a bony prominence known as the medial malleolus. This bony prominence is also more commonly known as the inner ankle. The fibula is the laterally situated and more slender of the two long bones of the leg. At its proximal end is the head of the fibula. It has an irregular shape and articulates with the tibia on the inferolateral surface of the tibial condyle at the tibiofibular joint. At the distal end of the fibula is a bony prominence called the lateral malleolus. You may know this bony prominence simply as the outer ankle. Finally, we'll look at the bones of the foot. The bones of the foot can be divided into the tarsals or the tarsal bones, the metatarsals, and of course the bones of the toes or the phalanges. The tarsal bones comprise 7 bones, which we're now going to talk about in a bit more detail. The first tarsal bone we're going to look at is the talus, which forms a link between the foot and the leg via the ankle joint. It's also known as the ankle bone and plays an important role in the stability of the ankle. The second tarsal we'll talk about is the calcaneus, which is also known as the heel bone. I think you'll agree with me that it's a bit hard to see from this perspective, so let's view it from its lateral aspect and zoom in a bit. So now we can see that the calcaneus sits just below the talus, that it's the largest of the tarsal bones, and that it projects posteriorly to form the heel of your foot. The navicular bone is also a tarsal bone and is situated on the dorsum of the foot. If we view the navicular from the sides posteriorly to form the heel of your foot. The navicular bone is also a tarsal bone and is situated on the dorsum of the foot. If we view the navicular from the side and zoom in, we can see how this bone relates with the other tarsals of the foot. It articulates with the talus proximally, the cuboid bone laterally, and with the 3 cuneiform bones distally. However, we can only see 2 of them in this image. Let's move on to talk about these bones. There are 3 cuneiform bones which are situated on the medial side of the foot: the medial cuneiform, the intermediate cuneiform, and the lateral cuneiform bone. Along with articulating with the navicular bone proximally, the cuneiform bones also articulate with the cuboid laterally and with the proximal surfaces of the 1st to 3rd metatarsals distally. The last tarsal bone is the cuboid bone. If we view this bone from the side and zoom in, we can see that it articulates with the calcaneus posteriorly, the lateral cuneiform medially, and the 4th and 5th metatarsals anterolaterally. Let's move further distally to look at the metatarsals. There are 5 metatarsals of the foot that connect the ankle to the toes, and they are named 1 to 5 from medial to lateral when you look at them from the dorsal surface of the foot as we are now. The metatarsal bones are connected to the phalanges of the foot via the metatarsophalangeal joints. The final bones of the lower limb that we're going to look at are the phalanges of the foot. These long bones of the foot are situated distal to the metatarsals and make up the bones of the toes. Each toe is comprised of 3 phalanges with the exception of the big toe, which is comprised of only 2 phalanges. And we can see this better if we zoom in on our image. The 2nd to 5th toes are comprised of a proximal phalanx, a middle phalanx, and a distal phalanx. Each of the phalanges are connected to each other via joints known as the interphalangeal joints. Note that the 2nd to 5th toes each form 2 interphalangeal joints. The big toe, on the other hand, doesn't have 3 phalanges. The big toe, or hallux, is comprised of only a proximal phalanx and a distal phalanx. This means that while the other toes each form 2 interphalangeal joints, the big toe only forms 1 interphalangeal joint. You'll be glad to know that we're coming to the end of our tutorial, but before I let you go, let's discuss some clinical notes relevant to the skeletal system. Like any tissue in the body, bones can also be affected by disease. For example, bone can become cancerous. There are several types of bone cancer, but we'll focus on 2 types today: osteosarcoma and chondrosarcoma. Osteosarcoma is the most common type of bone cancer, and it arises in bone cells. This cancer mostly affects individuals under the age of 20. Chondrosarcoma, on the other hand, arises in cartilage cells and mostly affects individuals over 40 years of age. Bone diseases can also arise as a result of malnutrition. Rickets is a condition that affects bone development in children. It's caused by vitamin D deficiency and results in the bones becoming soft and weak. This can result in deformities like we see here in this X-ray, which shows the characteristic bow legs that can arise in individuals with rickets. So that's us finished for today. Let's summarise what we've covered throughout this tutorial. So the first thing that we learned today is that the skeleton can be divided into two main parts, the axial skeleton and the appendicular skeleton. We then saw that the axial skeleton consists of the skull, which can be divided further into the bones of the neurocranium and the bones of the visceral cranium. The axial skeleton also consists of the trunk, which includes the vertebral column or the spine, the rib cage, and the breastbone or the sternum. Next, we looked at the appendicular skeleton, which consists of the shoulder girdle, the bones of the upper limb, the pelvic girdle, and the bones of the lower limb. We looked at the main bones that make up each region and also discussed some important features of these bones. So that brings us to the end of our tutorial on the skeletal system. I hope you enjoyed it, and thanks for watching.